Welcome back to another lesson on Windows PowerShell. In this tutorial, I will go over arithmetic operators. There are various types of operators built into PowerShell. That includes arithmetic operators, assignment operators, Boolean operators, etc. When writing scripts in PowerShell, it is important to understand how these operators work. Today, I will go over the arithmetic operators, and in the next few tutorials, I will cover the rest. First thing I want to talk about is the operator precedence. If you look at this statement, so this expression 3 plus 2 multiplied by 2, and the next expression going to be 2 multiplied by 2 plus 3, and if I run these two lines, you will notice that both of them return the value 7. Both result in value 7, even though this one started with 3 plus 2 multiplied by 2, and this one is 2 multiplied by 2 plus 3 is both return 7. But why is that? Shouldn't this expression be different from this expression? Because this is like 3 plus 2 multiplied by 2. This is 2 multiplied by 2, then added 3. The reason why both of these expressions return the value 7, because the multiplication operator has a higher precedence than the addition operator. So in PowerShell and in many other languages and scripting and programming languages and math in general, we usually do the multiplication first, and then by convention we take the addition next. So it doesn't matter that the 3 is at the front of the expression or at the end of the expression. This will always do the multiplication first. So it's going to go 2 multiplied by 2, 4, then add 3 to it, it will return 7. Or it will do again here 2 multiplied by 2, add 3 to it, and it will return 7. So there is a precedence that is already built into arithmetic operators in Windows PowerShell. And all the other operators also have those precedents baked into the PowerShell program that will allow us to enter this expression either way and return 7 here. So if you want to change this behavior, you can do that using a higher precedent operator like a bracket. So for example, if I put a bracket and then put 3 plus 2 inside that bracket, then I multiply by 2, this will result in 10. So if I clear this and if I run the whole thing again, you'll notice that this expression, for the first expression, it returns 7, second expression, it returns 7, but the third expression, it returned 10, because in this situation the bracket takes higher precedent over the multiplication. Therefore, instead of doing 2 multiplied by 2 first, what it did actually, it added the 3 to 2, so that will give you 5, and it multiplied 5 by 2, now end up giving us 10. So because bracket is in a higher precedence over the multiplication, it took the precedence and did that part first before going into the next. Now, how do you know that these type of arithmetic calculations will run through that type of precedence order? Well, in general math, typically we do the multiplication first and then you do the addition. Doesn't matter which order it comes in unless there is a bracket. It always bracket first, then it does the multiplication next, and so on and so forth. So how do you know what is baked into PowerShell. PowerShell typically follow the same arithmetic principle as any other math class that you have taken in elementary school or elsewhere with respect to arithmetics. But PowerShell also have few other things like Boolean and other things that operators baked into it. So to get all these precedence information, or like which is have a higher precedence or the other, we can use the get help commandlet. Recall from our previous lectures, we can type get-help commandlet, and then we can put something in front of it to get any help data associated with that, right? So if I go about underscore operator precedence get help, so get-help commandlet about operator precedence, if I run this, that will return all the available support information that I have associated with the arithmetic and other operations, so operators I mean. So if I clear the screen terminal here, and if I just run this part of the command, and you can see in here it return bunch of information. If I go to the middle of that, right around here, there's a list showing operator and the reference, and you can see that the multiplication comes before the addition or subtraction, and that's why when I enter 3 plus 2 multiplied by 2, it ran the 2 multiplied by 2 first, which is 4, and added 3 next, instead of going in the order which is being entered, because it has a higher precedence right here. Brackets, on the other hand, have a higher precedence even than this, because it is on the higher up of the thing in terms of precedence, and that's why it changes the way that this being interpreted. So if you don't know how the precedence is set for any of the items in our PowerShell, you can actually pull that information using the get help commandlet and about underscore operator underscore precedence expression. You enter that expression in front of the get help and then press enter. You run that command, and this is what you get, and that will give you all the information you need. Also, there are other features baked into this as well, such as other operators I mean, such as the binary operators, split options, etc., which I will cover in a later tutorial. So if you want to know quickly some operator precedence information, this is how you can get it. So I'm going to clear the screen here on the terminal, and next thing I'm going to get into is that how we can use these arithmetic operators to do certain things in PowerShell. So let's focus on addition and subtraction operators in this particular category, in arithmetic category. So we typically use the addition operators on numbers, right? Even in here at the very beginning, when I just introduce you to the operators, arithmetic operators, I use the addition and here, right here, and the addition right here and right here, right? So that means that you can add two numerical values together using the addition operator. For example, 2.71828 I want to add, so it could have decimal places, 3.14159 or something like that, and if I run this, and it will add this value to this value, and it will output 5.85987. that is the addition of these two values. But we can also use this addition operator in PowerShell with strings. In other words, the PowerShell has a way of using this addition operator to combine or concatenate strings. For example, if I type Sanuja, I put a plus, and if I put Senanayaka, and if I run this, what that will do is basically it will add Sanuja string to Senanayaka string. So this addition operator not only can add numerical values, it can also combine or concatenate strings. So if I run this part of the code, it added Sanuja and Senanayaka. Notice it added the two strings as it is. It didn't add any spaces in here or anything like that. It just took this string and combined them together. If you want to add a space, you either have to add a space in here or space right here. So if I run this now, it will have a space between Sanuja and Senanayaka, and this space is actually coming from right here. So this addition will just take two strings and just combine them as it is, unless there is a space or something in front of it within the next string. So in PowerShell, we can use the addition operators to not only to add mathematical values together, but also you can use it to concatenate strings. Another built-in feature of PowerShell is that you can try to concatenate a string with a number, and it is possible. And what that's going to do is that it will convert the number into a string, and the output would be in a format of a string. What I mean by that is, if I clear the screen again here, and if I go with, let's say, Sanuja, and if I put plus here 21, if I run this, this is still a valid command. This is still a valid code, and what that will return is Sanuja 21. But at this point, this is no longer anything. This 21 is no longer a mathematical expression. It is a string expression. In fact, if I put this into a variable, let's call this var, just because, let's put var test. No, just put var, that's fine. And if I get if I put var in here, would get type, and if I run this now, it will get you a string. So even though this is a numerical value and this is a string, what this addition operator has done here is taking that string and convert that string, whatever it sees after that string, into strings. In other words, it started with a string, and whatever they sees on the right hand side after this addition sign gonna be string. It doesn't matter what it is, it's just gonna convert that into a string, and the final outcome would be a string. Now you might think this would work in either direction. So in other words, like, what if I put 21 at the front here and add a string on the right hand side? So this doesn't work. Why? Because the conversion of a number to a string only works when the number appears on the right hand side of the addition operator. So if you have the addition operator on your code, and if you don't have a string on the left hand side, you have a number at the left hand side, but on the right hand side you have a string, it will fail and it will give out a spit out an error message. For example, if I rewrite this to 21 plus Sanuja, let's get rid of this. So instead of having Sanuja plus 21, I have 21 Sanuja. If I run this now, it will spit out an error message, because reason for that is as soon as the PowerShell sees a number, it is only going to look for numbers to add to this 21. So anything that is showing up on the right hand side has to be a number. With string, remember, you can have Sanuja plus 21, because it will just simply take the string here and anything to do with right hand side, it will convert to a string. So the PowerShell can convert a numbered value to a string, but it cannot convert a string to a numbered value. So because this is started out with a string, this addition sign basically look at everything on the right hand side as a string, and it's going to take this number 21 as a string value and then coordinate or combine these two together. But in here, it goes through the same process, but now it starts with a number. So after this addition sign, what PowerShell is looking for on the right hand side is a numbered value, and when it doesn't see that it sees a string, it's going to spit out an error message. And here it says invalid argument, cannot convert value Sanuja because the system, this is in int32 format. So if I clear this screen again, I can run just these two, and you will notice the first part, this part of the code, it did spit out Sanuja 21, no problem. It converted number 21 to a string, but in here on the next line, it is an invalid argument, because when it read to number 21, it is a numeric value, and the next one is a string value on the right hand side, and it cannot add them together. So what you need to understand here is when we had the string on the left hand side, the PowerShell was expecting the entire expression to be a string. Because number 21 can be a number 21 or a string 21, it can convert that 21 into a string and spit it out a combined value, a combined output of or concatenated output of Sanuja 21. However, but when the number is appearing at the left hand side of the plus operator, instead of converting this 21 into a string, now this code is basically at this point is a numbered or value. So it cannot now change that into a string as it sees the string on the right hand side. So you can combine a string with a number, but not with a number with a string, because of the way that the PowerShell operates. So again, I'm going to repeat that. This is a very important concept. When we had the string on the left hand side, the PowerShell was expecting the entire whole thing to be a string, because number 21 can be converted into a string, no problem. But when we have the number 21 on the left hand side as opposed to right hand side, it can do that, because reason for that is now they are looking for numbers. Everything after plus sign, the PowerShell is looking for numbers, and you see a string, it cannot convert that into a number because there is no equivalent number for Sanuja string. So it spit out an error message. Now let's move on to the next part of this. Now the addition operator can also be used with other items that we have covered in my previous tutorials, such as arrays. So for example, recall from our tutorials 7 and 8 how we can create an array. Remember, we can use the @ symbol, and then we can use the bracket, and I can say 1, 2, and that will give us an array with 2 values in it. I'll put a space in here so it's easy to see. So this is an array with 2 variables. So if I run this, it'll just gonna spit it out an array with 2 variables, 1, 2. Now let's say I want to add a value to this array. I can do that by simply typing in the array, again 1, comma 2, and I can simply put the addition operator here and put 3. Now if I run this array again, it will have 1, 2, 3. So the addition operator can be used with arrays to add value to an existing array. So you have an array that only have 1 and 2, and with this addition operator I can add the number 3 in there. Now we have the array 1, 2 and 3. So what if I did something like this? What if I want something like let's say 1, 2, and then I want additionally added 3, 4. So I want 1, 2, 3, 4. Like I don't want just 1, 2, 3. I want a whole bunch of items there, right? You can you can add 1, 2, 3, 4 into this by simply adding another number right here. If you do that, and if I run this now, it will result in 1, 2, 3, 4. So initially start with an array with number 1 and 2. You can either add just one number, or you can add multiple numbers like this, and what that's going to result in basically changing this array and adding all of these values and putting into that array. Now it has 1, 2, 3, 4, 5, 6. So the addition operator can be used to add values into an array by simply putting that addition operator in front of the whatever the value that you want to add to that particular array. With addition operator, you can also combine even multiple arrays and values in few different ways. So in addition to adding values into the array, you can actually combine arrays. So for example, I'm going to clear the screen here. Let's say I have an array 1, 2, and I have another array let's say 3, 4, right? So if I can put an addition sign in between the 3, 4 array, what that will do is combine this 1, 2 array with the 3, 4 array. So if I run this now, what that did, it combined the 1, 2 array with 3, 4 array. So the addition operator can combine 2 arrays together as well. Now you can also use the addition operator with our hash tables. Recall from our previous tutorials, I already went over hash tables. Hash tables are different from arrays so that it has a key value pair, and in a similar manner that we have added these items together using the addition operator with arrays, you can do that with hash tables. Remember, hash table, again we start with the @ symbol. Maybe I shouldn't delete that. I will go undo. So let's do a hash table here. So the hash table, again we start with the @ symbol, but now we put that curly bracket, and we're gonna have to have a key value pair. So I'm gonna say key1 equal to 1, and I'm gonna combine that with another hash table key value, and it has to have again @ symbol and a curly bracket, and I can go key2 equal to 2. Now what this has done is combining this one into one single hash table with the key1 and key2 in it. Now if I run this code, it will result in key1 as 1 and key2 as 2. Remember, hash tables are not ordered in any way. Even though the key1 came here first and key2 came here second, it's not ordered in any way, so that's why the key2 came on the bottom here, but the hash table is built now. Another feature of this addition operator is that if you rerun this, it will fail, because unlike the in some other operations with hash tables, you can have the same key entered twice, right? So if I rerun this, it should give me an error message. So let's clear the screen. So let's rerun this. So I'm going to run the exact same command twice. So we create a hash table like this, and we're going to add it to the same hash table. That should return an error message because it can't have the same value twice. So you may have noticed that it didn't return an error message. Why is that? So we have the key 2, and we have a value here, and a key 2 again, and a value here. So why did this hash table didn't return an error message? Remember, recall from our hash tables tutorial, you can have two keys with the same value in the same same two keys. Like you can have key 2 twice appearing or key 1 twice appearing in a hash table. That is not allowed in hash table. So what's happened here? What happened here is basically it went through this line and created a hash table, and went through this line and created a separate hash table. So these two hash tables are not the same. There are two hash tables going on here. To prove my point, what I can do is I can change this to key 1. And if I run this, it will return an error message because now I'm creating one hash table here with the same key appearing twice. So if I run it, operation stop, the item has already been added, and you can have key 1 twice. So keep that in mind. So when you're using the addition operator, if you combining hash tables like this way, you would expect an error message if we type something like this. But as you can see, it did not return an error message because it's just creating two hash tables with key 1 and key 2 included in each hash table. So this hash table is independent of that hash table. But if I put the same key into the same hash table, let's say key 2, it doesn't really matter, key 1 or key 2, and if I just try to run that, what that will spit it out is a operation stop error because you can have two keys with the same key name on it. So that's something that you should know when using your addition operator. So I'm going to clear the screen because the next thing I'm going to cover is the subtraction operator. So unlike the addition operator, which has some neat little features such as adding strings and numbers and combining hash tables and etc., the subtraction operator can only do one thing, that is subtract numeric values. So unlike the addition operator, which has some additional functions that we can use, such as concatenate or combine strings, combine values and string, and work with the hash tables and arrays, the subtraction operator only can do subtractions. That's only numeric values you can work with. So for example, 5 minus 2, that's a valid operation, and if I run it, it'll give me 3. Obviously you can have negative values as well, so you can have something like that. If you run that, it'll give me 18, negative 18. This is negative, this is positive 3, the other one is negative 18. So you can use this to work with numeric values. So there's nothing much to discuss here with respect to subtraction operator. It works exactly how it is expected to be worked as a numeric mathematical calculation when we do it, right? So then basically it's subtract a value from another value. It's subtract 2 from 5, is subtract 20 from 2, and spit it out plus 3 and negative 18. So that's all the subtraction operator can do. The next operator I want you to know is the multiplication operator. Everyone probably already know that the multiplication operator can perform simple arithmetic operations. So just like these simple arithmetic operations that we did with the subtraction operator, you can go with 2.5 for example and multiply by 2. And if I run this, it's simply gonna multiply 2.5 by 2. It will give me 5, and that is correct. But in PowerShell, just like the addition operator, it can do little bit of more things with it, the multiplication operator. So unlike the subtraction operator in PowerShell, the multiplication operator can use with some other functions that are baked into PowerShell. So for example, let's say I want to create duplicates of strings. So I am going to type my name Sanuja. If I print this, it will just going to give me one Sanuja. But let's say I want Sanuja, Sanuja, Sanuja printed here, right? I can do that with adding Sanuja here. So I'm going to clear this. So if I run this right now, you can see 2.5 multiplied by 2 give me 5, and Sanuja just print Sanuja because it's a string. But if I put multiplication here, and then if I put an integer, let's say like 5, what that is going to do, it's gonna have 5 times Sanuja, 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 Sanuja. So like if I run this now, see, printed Sanuja, 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 Sanuja 5 times. 1, 2, 3, 4, 5. That because of it took the string Sanuja and it went ahead and multiplied that by 5 times. So I put an integer there, right? So I can put, for example, 2, and if I print 2 right here, it's going to print Sanuja, Sanuja twice. What happens if I put 2.75? And what happens if I run this? What's going to happen? Well, what that did is, in this situation, it took the string and it saw the multiplication. So now this is already in the string mode, like a string, right, type. Look at the right hand side. Look at this number 2, and it rounded up to 3, and it printed Sanuja, Sanuja, Sanuja 3 times. So for example, if I put 2.1 here, and if I print it again, what that's going to do, it's going to print only Sanuja twice. So when I had 2.75, it printed 3 times Sanuja. When I had right here, so when I had Sanuja multiplied by 2.75, it printed 3 times Sanuja, because 2 into rounded up to a 1, like an integer value, it's going to be 3, so it's going to print 3 times. But 2.1 rounded to a integer value, it will give me 2, because it's going to get round down. This is going to get round up. It will give me Sanuja, Sanuja. So basically, it saw a string on the left hand side and it saw a value on the right hand side. If it is not an integer, it converts itself into an integer and print the string here on the left hand side on number of times which this integer is asking it to print. So in here it printed twice, and I put 2.75, it printed 3 times because it rounded up to integer 3. Now, as with the addition operator, the multiplication operator will also throw out an error message if the number value is on the left hand side of the operator. So if this 2.75 on the left hand side of the operator, I'm going to clear the screen here. So if I run this, it's just fine. It prints 3 times Sanuja. But if I put 2.75 multiplied by string Sanuja, that will spit out an error message just like our addition operator. Here you go. It says invalid argument cannot convert Sanuja string to the double that we have, because initially we had a double which is 2.75, and it's not going to convert to integer at this point because it's 2.75 is a valid double. There's no need to convert it, and now it sees a string on the right hand side. it can do anything because the string cannot be converted into a double, and therefore it gonna spit it out an error. So this is a valid expression because the string is on the left hand side of the multiplication operator. This is an invalid expression because the string is on the right hand side of the multiplication expression, and therefore it's going to spit out an error message, just like it happened with our addition operators. See right here in the addition operator, if I run that, it spit out an error message because the numbered values on the left hand side with the addition operator and the right hand side being a string doesn't work. But if the string is on the left hand side, it can convert that number 21 into a string. And the same idea here, except with the multiplication, if you have a value on the right hand side, a numeric value, it will round up or round down based on its, whether it's 2.75 or 2.2, for example. And when you run it, it will print the string 3 times. But when you have a numeric value on the left hand side and a string on the right hand side, it will spit out an error message, because at this point when it gets to here, it is already have casted into a numeric double and it can't convert this string into a double. So the same principle that we saw with the addition operator applies to our multiplication operator as well. So having said that, next thing I'm going to show you is that how we can use these multiplication operators with arrays, just like before that we have used it with arrays. Up here, the addition operator, you can use the multiplication operator with arrays. So let's create an array. So let's go with, I will give you an example of this array. So let's create an array with some strings in it. So I'm going to call 1, and then I'm going to 2. And if I'm go with multiplication here, and I'm going to put a few more arrays just to show you, it works. What this is going to do is just going to, multiply this array by twice. So if I split it out, what it did actually have 1, 2, 1, 2, because what it did, I took this 1, 2 and multiplied by twice. If I put 5 times, it'll print 5 times. It's gonna see 1, 2, 1, 2, 1, 2, 1, 2, 5 times. So the multiplication operator can be used with arrays to, work this way, and you can actually do this way as well, or this way as well. These are still valid expression. If I run this, it's a valid expression, still works. Do this, still works. So basically all these 3 expressions, taking this array and then converted it into 5 times. So for example, 1, 2, 3, 4, 5. So this is same as writing as this and same as writing as that. So all of these 3 expressions basically created a duplicate arrays with, by multiplying the array we have in front of it by whatever the value you are putting in. If you put like twice, it's just going to do twice. If you're going to do 5 times, it's going to do 5 times. You can put, very large values too. It'll just repeat that large value. Like for example, if I put like 1000 times, it's just going to run 1000 times. So that's how the multiplication operator works. I'm going to clear the screen again, and the next thing I'm going to cover is the division operator, which is basically kind of an opposite to multiplication, right? So to divide numbers, we use that division operator. For example, if I want to divide 20 by 5, I put the division operator in the middle like that, and that will divide 20 by 5. If I run this, it will spit it out 4 because it does 4 5s in 20, right? You can also do divisions where 20 divided by 45, for example, there's nothing, no 45s in 20, it'll spit it out a the decimal value, a fraction value on your terminal. You can also do the negatives and positives as well. So example, negative 20 divided by positive 5, that should give me a negative value. So if I run it, it's negative 4. Yeah, that's correct, because 20 divided by 5 is positive 4, minus 20 divided by 5 should be negative 4. And if I divide negative 20 by negative 5, that should give me again back to a positive value, because that's a negative value divided by negative, and yeah, it works as expected. Now these are basic division arithmetic operations that you can do with any programming language or scripting language. One thing, however, that in any programming or scripting language that people have to be careful about is the division by 0. In PowerShell, it also do the error with the division by 0. So you can use that for some advanced scripting for error handling. For example, if I get the 20 and divide by 0, and if I run this, it should spit out an error message. There you go, runtime exception attempted to divide by 0. So if you're running a PowerShell script and it somehow got into a position where it start dividing by 0, it will spit out an error message, and you can use this runtime exception spitting out error to catch that error message and do something with it. So just like as expected, the division by 0 will give us an error message. And the final thing I want to cover with arithmetic operations in PowerShell is the remainder operator. So I'm going to clear the screen again here. So let's say I have number 3 and I want to divide that by 2. But I don't want the decimal value of 3 divided by 2. I want whatever the remaining value of 3 divided by 2. So if I run this now, what that's going to result in is 1, because there are 1 2's in 3, right? So that's 2 plus 1 give us 3. So there's 1 remainder. Another way to look at it is, let's say if I need to divide 100 by 90. So how many 90s in 100? Well, if I run this, there are 190s in 100. The remainder is 10, value 10. So the 100 divided by 90 will give me 10. The reason for that is there's 190s in this 100 and the remainder going to be 10. So the remainder operator is used in many computer programs and scripts to perform various functions, and it is a very useful operator to do certain things, especially in for loops and while loops sometimes. And I will cover that in depth in our future tutorials. What you need to remember is what the remainder operator is doing here is basically remainder or remaining value of a division is being spitted out onto the terminal or save it as a value in a variable, right? So again, like for example, another example of, say, if I put 50 divide by 45, and if I run that, how many 45s in 50? 1. But remaining is 5, so it spit it out 5. So that remainder operator will give whatever the left over after dividing a value. So whatever the leftover is the one that we are looking for when we are using the remainder operator, which is this percentage sign. So that's everything for today. I have covered all arithmetic operations available to us on your Windows PowerShell, and those includes we start with some basic stuff such as the positive addition, and I introduce you to subtraction. And remember, subtraction operator can only do subtraction between numbers and nothing else, compared to some of the other operators that we looked at. For example, positive operator. We also introduce you to the multiplication operator, which also can work with strings as well as numbers and arrays, etc. I also introduce you to the division operator, which also can mostly do work with only numbers. And finally, I introduce you to the remainder operator, which give us the remainder of a divisional operation. So these are very important concepts that you should understand when it's come to performing arithmetic operations of Windows PowerShell 7. In our future tutorials, I will go over assignment operators, Boolean operators, and few other operators such as comparison operators, etc., etc., that may be very useful when you are writing PowerShell script. If you have any questions or concerns regarding any of the items we have covered today, please don't hesitate to reach out to me. If you like these tutorials, please thumbs up this video and subscribe to my channel. And until next time, thank you so much and have a nice day.